We're taking a deep dive into the world of moon rocks and the mind-blowing technology that NASA uses to study these remarkable rocks from space. Next on Real World. The moon, our closest celestial neighbor, has fascinated humans for centuries. Thanks to NASA's Apollo missions, we have been able to bring back rock samples from the moon and study them in detail. But how many samples were collected, and what do we know about them?
Across the 6 Apollo missions, they collected 2,196 individually numbered samples. There are so many different types of sample that they brought back. The biggest division is rocks versus soil. So they brought back about 2/3 rock and about 1/3 soil. Within each of those divisions, you have different types of rocks. You have rocks that are what we call igneous. They form from molten lava. And then we have rocks that are sedimentary that form through impact processes. And so each of those answers different questions about the moon. And then with the soils, we brought back surface soils and deep deep soils. And each of those tells us something different about solar system and lunar history. When we talk about soil on the moon, it's really what we call regolith, and the difference is soil involves a chemical process. So soil on Earth has worms in it, it has water, there's a chemical breakdown of the material into soil. The moon doesn't have any of that. The moon is entirely a physical process, and so we call that a regolith, but most people think of it as soil. Math is used every day at every level when we curate the samples and when people study the samples. At the most basic, we have to keep track of the mass. So we have to be able to add and subtract. As we started with a kilogram of sample, and then we subtracted off 100 milligrams to send to you. Now how much do we have left? So that's very basic, but it's very important because it's what lets us know how much we have left. We've also used math to calculate the density of a rock. And so density equals the mass of something divided by the volume of the material you're weighing. So if you know how much it weighs and you know how big it is, then you can figure out the density. So the normal way to calculate the density of a rock is to actually just to weigh it, and then you need to figure out the volume of the rock. And you could figure out the volume of a rock by using a laser 3D scanner, and in fact this is done quite commonly on terrestrial samples where you put the rock and you scan it with a laser and it gives you a very precise volume, and then you weigh it, and then the density is relatively straightforward to figure out. After that you just divide the mass by the volume and there's your density. Once the scientists get the samples, they use math in everything they do.
Whoa, there are so many different types of samples available for researchers to study, and so many different ways for them to study them. But how do we protect these samples, and how do we make sure that they are not contaminated with particles from Earth?
We're working in a clean room for the fact that we need to keep the samples that came from the moon in the same pristine state that they were in when they were collected. It's important to use a clean room because we want to make sure that what's being analyzed is actually from the moon versus analyzing what's actually on Earth. There were 6 missions that the astronauts brought back. 842 pounds of rocks, 382 kilograms of rocks are processed in nitrogen-filled cabinets in the Lunar lab, and we process them in that environment so that we're not contaminated. The Lunar lab is actually an ISO 6 lab. We have a return processing lab that's actually ISO 7. Those ISO numbers are government numbers saying the cleanliness of laboratories. There's procedures step by step in order to enter the laboratory. We actually don a hat, booties, gloves, bunny suit. These rooms are all pressurized so that the clean air is flowing outward and dirty air doesn't go in.
Whoever would have thought that a rock would need to be so clean? Now that we know about the different types of moon rocks that we have and how we protect them from contamination, what kind of math is used to help curate and process these lunar artifacts?
When a sample is processed, the database has the original weight that was given when the sample came back. So that mass is recorded in the database. So once we weigh the sample, it has to be within the balanced tolerance. That's where our math is involved. NASA waited 50 years to open up the samples that they had on reserve until someone would put in a request that was different using updated and different technology, because technology definitely has changed from the 70s to now. With the CT scanning, you can look at a sample and you will actually see what's inside of a sample. If it's a large class, if they're small classes, before you even decide, I want to break this rock, you know what's inside of the rock.
These rocks are out of this world. Seriously, they're from the moon. It truly is amazing that we can learn so much from an object as simple as a rock. And thanks to the work from rock stars like Ryan and Andrea, we are one step closer to understanding and appreciating the wonders of our universe. And that is rock solid. See you next time on Real World.